Commerce, Manufacturing, and Trade will now come to order. I'll recognize myself for 5 minutes for the purpose of an opening statement. And today we're continuing our Disruptor series and focusing today on additive manufacturing, also what is known as 3D printing. Additive manufacturing has disrupted the industries it has impacted, not just by challenging incumbents, but also by lowering cost and increasing efficiency. Harnessed properly, this is another example of how innovation is creating jobs and opportunity and helping set the stage for a revival of manufacturing in the United States. Additive manufacturing has been around since the 1980s, with the patent for stereolithography issued to Charles Hull, the founder of one of the companies testifying today, 3D Systems. About 30 years later, surveys show that about 2/3 of industrial manufacturers say they are implementing additive manufacturing either by experimenting or using it to create prototypes of finished products. And the 3D printing industry is expected to grow from about the $6 billion it is today to over $20 billion in a mere 5 years' time. 3D printing has already woven its way into our manufactured products in subtle ways. For example, some of the commercial airliners we all fly will soon use 3D printed parts in their engines, and GE will testify about that today. Many of the cars on the road have had their development sped up dramatically thanks to 3D printed prototypes. Additive manufacturing has plugged itself into a growing proportion of the manufacturing supply chain because the designs are flexible and they are a naturally better solution for certain tasks. But 3D printing is also making a splash in less subtle ways. People around the globe are benefiting from prosthetic limbs, which were otherwise unaffordable. Surgeons can create accurate surgical guides, which reduce errors, and as a result will save lives. Scientists have begun experimentally printing human cell structures using a person's DNA, a result that is a logical use of life's own building blocks, but certainly potentially revolutionary for patients. In my district, 3D printing is enabling businesses to get the job done more efficiently. I have a constituent back home. His name is Adrian Murray. He runs a hot rod modification shop called Painless Performance, and he provides customers with custom wiring harnesses for their classic cars. These parts are no longer manufactured on an assembly line, but using a 3D printing prototype offered by Specialty Equipment Manufacturers Association. Painless Performance is able to speed up the development process. And I think we're going to show a video clip of that if the technology doesn't fail us, and I'll continue talking while that runs. As the subcommittee with jurisdiction over vehicle safety, we are especially interested in ways that vehicle suppliers and manufacturers are using polymers and plastics to enhance safety. Can we just turn the sound down on that because it's mostly the visual that we want? Carbon fiber reinforced plastics have 12 times the energy absorption capabilities while adding half of the weight of some comparable metal parts. Additive manufacturing is helping automakers and parts suppliers integrate these innovative materials into cars, which is making us safer and improving fuel efficiency. As 3D printers become more affordable, the universe of people able to print 3D print objects on their own expands. You know, one of the things in research for this hearing, my staff found an article for me. It's actually from Australia. It talks about Ralph Mobes, a neurosurgeon from Prince of Wales Hospital in Sydney. And in resecting a tumor in a patient, he had to replace the top 2 vertebrae. Pretty difficult operation, and obviously without the proper type of prosthetic, it would have been impossible. So the surgeon worked with an Australian medical device manufacturer to craft replicas of the patient's top 2 vertebrae out of titanium. And I just want to read you a quote from the surgeon. And mind you, he's from Australia, so he talks funny, I'm sure. To be able to get the printed implant that you know will fit perfectly because you've already done the operation on a model, it was a pure delight. It was as if someone had switched on a light and said, "Crikey, if this isn't the future, well, I don't know what is." So Dr. Mobes, I agree with you. If this isn't the future, I don't know what is. I'll now turn to Ms. Clark from New York, ranking member of the subcommittee, for an opening statement.
Good morning, Chairman Burgess and members of this morning's panel. Mr. Chairman, thank you for holding this hearing on 3D printing. For many of us, when we think of 3D printing, we think of plastic toys, keychains, and other trinkets. But 3D printing is about more than just the novelty of printing in plastic. This technology has many applications that we're only starting to explore. 3D printers enable small-scale personalized production that gives consumers more choice and convenience. Consumers can order affordable custom printed items from cell phone cases to shoes and prescription eyewear. 3D printers help product designers by allowing them to print prototypes more easily. Manufacturers can print replacement parts on demand. Prosthetics can be customized to make people who have lost a limb more comfortable. And recently, a 3D printed vertebrae, as our chairman has indicated, was implanted into a child with bone cancer. While today we're mostly printing in plastic and metal, 3D bioprinting opens a whole new world of possibilities in the medical field. Doctors may one day be able to grow needed organs for transplants or skin for prosthetic limbs or skin grafts. The future potential of this technology is one more reason why we need to increase our federal investments in research and innovation. But as we think about the tremendous potential of 3D printing, we also need to consider possible risks and challenges. Here are some of the questions on my mind. How should we protect consumers when the consumer doesn't buy the product, but rather the blueprint to make a product? How does 3D printing work with our existing laws on intellectual property? And what should people be able to make with 3D printers? I'm especially concerned about 3D printed weapons. Think about this. If someone has access to a 3D printer, all they need is the right blueprint. When the gun buyer is now the gun manufacturer, who does the background check? Who's responsible for keeping weapons out of the wrong hands? This isn't theoretical. The first 3D printed gun was made 3 years ago. An all-plastic gun would be a violation of the Undetectable Firearms Act. But a law banning the manufacture of non-metal guns only goes far when a plastic firearm can be made at home. And we may not be far from seeing metal guns being printed at home. Those who design blueprints for 3D printing and provide 3D printing capability must take responsibility to ensure that their business does not endanger other lives. And we in Congress need to make sure that our laws are up to date with today's technology. I look forward to hearing from our witnesses on the potential for 3D printing, as well as your perspectives on how we deal with some of these challenges. Having said that, Mr. Chairman, I yield back.
Chair, thanks. Gentlelady yields back. Chair would inquire of Mr. Pallone if he seeks time for an opening statement. Recognized for 5 minutes for an opening statement.
Thank you, Mr. Chairman. 3D printers and the products they produce have the potential to transform and improve our lives. It's remarkable to think about what is already possible in this space, not to mention the possibilities for the future. Today, 3D printers are driving innovation in American factories, schools, hospitals, and homes. All around the country, health researchers are using 3D printers to develop new approaches to tissue transplant and regeneration. The level of customization permitted by 3D printing can allow prosthetics, hearing aids, and dental aligners to be made more comfortably, effective, and affordable. And now think about the potential for 3D printers to transform the way cutting-edge medical care is distributed. The latest and greatest discoveries would no longer be limited to those who have access to a select group of medical facilities. Instead, 3D printers could help to easily reproduce new treatments and therapies at any hospital throughout the country and the world. 3D printing technology also has the potential to help build a more dynamic and inclusive workforce. At Rutgers University in my district, innovators created 3D printed braille maps that make a local vocational training center easier to navigate for the visually impaired. Additionally, 3D printers allow people to create prototypes of new designs or inventions at a lower cost than traditional production techniques, thus helping underrepresented communities gain access to entrepreneurship. The development of 3D printing technology is a great example of how effective public-private partnerships can be. This administration and members such as Representative Kennedy have worked to strengthen federal support for 21st century manufacturing technology, such as 3D printing. And I look forward to hearing how the National Network for Manufacturing Innovation is working with companies such as those represented by our witnesses today to promote American innovation and safeguard the future of domestic manufacturing. And as with all new technologies, the further adoption of 3D printing, especially at home use, raises safety and regulatory questions. Many of us have seen the media coverage about 3D printed guns. While the ability to make guns at home may not be new, the ability to make them easily and cheaply poses new safety risks, and increasing the number of guns made outside of the registration process could increase the number of guns in the hands of criminals. In addition, questions have been raised about how to protect intellectual property as 3D printers proliferate. There have been concerns about some types of inks used in 3D printing containing BPA, a chemical that the FDA has banned from use in baby bottles and children's drinking cups. But 3D printing offers enormous possibilities for innovation in manufacturing, increased opportunities for entrepreneurship, and convenience and customization was not available before. So it's exciting to think about the possibilities, and I'm confident these innovations can be coupled with consumer protections so that they really can improve people's lives. Did you want some time?
I'll take 30
Yeah. Well, I'll yield you the rest of my time.
Thank you. Thank you very much, Mr. Bellone, and I want to thank the chairman for calling this hearing. I was really excited just to get a chance to listen to all of you and understand a little bit about how the National Institutes are going, building out the progress. I have been bragging about you like crazy for everywhere, so hopefully it's good. And very much look forward to understanding and getting some lessons learned from you about what's working well, where we can improve, and as other institutes are stood up around the country, how we can try to learn from your success. Most importantly, trying to understand how government can be a positive source for innovation and trying to lower some of the barriers to entry and the risks that local innovators take and small businesses take, and trying to make sure we can spur the next generation of manufacturing here in the United States. What that also means for workforce integration with our workforce training, all the way up the supply chain. So grateful for the opportunity to be here. Grateful that all of you are willing to come testify, and look forward to learning from you over the course of the rest of the morning. Thank you. I yield back.
Chair, thanks. The gentleman yields back. Seeing no other members seeking time, we'll conclude with member opening statements. And the chair would remind members that pursuant to committee rules, all members' opening statements will be made part of the record. And we do want to thank our witnesses for being here today, taking time out of your day to testify before the subcommittee. Today's witnesses will have the opportunity to give opening statements, and then we will follow with questions from members. Our witness panel for today's hearing include Mr. Neil Oringer, Vice President for Alliances and Partnerships at 3D Systems, Mr. Alan Amling, Vice President for Global Logistics and Distribution Marketing with UPS, Mr. Ed Morris, Director of National Additive Manufacturing Innovation at the National Center for Defense Manufacturing and Machining, and Dr. Herderick, Additive Technologies for the Additive Technologies Leader for Corporate Supply Chain and Operations within General Electric. So we appreciate all of you being here today. We'll begin the panel with Mr. Oringer. And Mr. Oringer, you're recognized for 5 minutes for an opening statement, please.
Thank you. Thank you, Mr. Chairman, Congresswoman Clark, and members of this distinguished subcommittee. Thank you for the invitation to address you today. I'm honored to discuss a critically important topic, how additive manufacturing is revolutionizing the delivery of health care. In 1983,
Mr. Oringer, is the green light on in your microphone?
it is.
Okay, may need to pull it a little closer. Again, I would stress that even though this is the premier technology committee in the United States Congress, we have pretty low-tech equipment, but please continue.
How's this? Okay. In 1983, my company's founder, Chuck Hull, invented 3D printing. He's applying a process called stereolithography to physically replicate an eye cup that was designed and digitally drawn on a computer. His patent was granted in 1986, and the business took off from there. More than 30 years later, the industry is in full throttle. For its own part, 3D Systems is the world leader in additive manufacturing and the only major US-based 3D printing company. But from the outset, we've catalyzed continuous innovation in healthcare. So I guess I would amend Dr. Moeb's comments and say the future is now. In the early 1990s, we revolutionized manufacturing of hearing aids, rapidly customizing the form and fit to an individual's ear with unparalleled precision helping build wireless devices with comfortable biocompatible materials. And today, 99.5% of all hearing aids are 3D printed worldwide. A decade later, we helped 2 graduate students from Stanford University discover a better way to straighten teeth. With our technology, they manufactured what became Invisalign, which are clear orthodontic aligners, as has been discussed. Today, Align is a world leader in mass customization, accuracy, and comfort, producing over 20 million individual aligners in the last 12 months alone. So 3D printing continues to advance significant breakthroughs in the field of precision medicine. Now, that's a movement that's been championed by the FDA that tailors medical treatments intensively to individual characteristics of each patient. So as part of this movement, together with genomics, regenerative medicine, computational biology, and medical imaging, 3D printing is once again revolutionizing the practice of saving and improving lives. Now, today I'd like to concentrate on 3 areas: vertical surgical planning, fabrication of advanced implants and devices, and new modeling processes. Vertical surgical planning is what I'd start with first. VSP empowers surgeons with unparalleled precision in the most complex procedures. It significantly reduces the time in the surgical theater and saves lives. Our experts interact directly with doctors, receiving data from CT scans, and then design and build surgical guides that are placed on a patient to support a particular procedure. We're showing a video right now in the hearing room to highlight the case of Blessing Maquira. He sustained a landmine injury to his upper and lower jaws, tongue, lip, and teeth. Blessing's spirit and courage are truly inspirational, and today he can smile. Now, 3D Systems worked with Joel Berger, an oral maxillofacial surgeon at Sharp Memorial Hospital in San Diego, California, to rebuild Blessing's face and give him new teeth. The fibula-free flap operation involves taking bone tissue and vessels from the fibula and reconfiguring them to form an upper and lower jaw connected to blood vessels in the neck. We use CT scans to extract 3D anatomical information needed to visualize the surgery in 3D and map out the surgical plan. Now, Blessing required a number of 3D printed tools, including a mandible and maxilla cutting tools, a lower and upper jaw, to guide the surgeon's saw blades in the operating room. It's an inspirational story among tens of thousands over the last several years. Models and simulation. Aside from the surgical guides, Blessing surgeons also use 3D printing models for reference during the operation. These models show surgeons what is hidden beneath layers of soft tissue, and they gave surgeons hands-on experience with Blessing's jaw and anatomy long before the surgery. Finally, I want to talk not about customized tools, but about how 3D printing is transforming wholesale production of medical devices and implants. I brought a titanium component of a hip transplant, which we 3D printed. Rather than go through the onerous process of building a cast model, or a cast mold, shaping and cooling and then coating a single part, metal 3D printing allows us to consolidate the supply chain, saving time and resources. It also allows us to add functions to the part with designs that maximize bone cohesion, structures that simply cannot be built via any other manufacturing process. So doctors and device manufacturers can send us data to engineer 3D models, and then we use direct metal printing to build dozens of these titanium cups in a single build process. We've been working with US and European regulators to ensure appropriate quality assurance in the process for an array of implants and devices. In all these areas, we have a strong and constructive partner in the federal government. As we work to receive appropriate qualification for these products, it's essential we maintain an appropriate balance between promoting innovation and ensuring safe delivery of care to patients. As 3D printing improves the economics in the production of critical healthcare tools, I'm hopeful we might someday see these efficiencies actually translate to lower costs for the patient. Integrating these novel processes and tools will require a greater understanding not only by the regulators, but the health insurance industry as well. Now, in due time, perhaps it'll be commonplace for these tools to be integrated into conventional billing processes. It's time for 3D printing to be appreciated as an important instrument for mainstream quality care. And I look forward to discussing this and other issues with the committee today. Thank you.
Chair thanks the gentleman. Chair recognizes Mr. Amling. 5 minutes to summarize your opening statement, please.
Good morning, Chairman Burgess, Ranking Member Schakowsky, members and staff of the committee, fellow witnesses, and attendees. My name is Alan Amling, and I'm the Vice President of Marketing for UPS Global Logistics and Distribution. And during my 23-year tenure, I've helped our business develop and grow across all aspects of the e-economy and to launch innovative new solutions like carbon-neutral shipping. While you are likely familiar with UPS's fleet of more than 100,000 brown trucks and our 425,000 employees globally, you may not know much about our supply chain business. More than 100 years ago, UPS started as a bike messenger in Seattle. In 2016, We operate one of the largest airlines in the world and offer global supply chain services, including ocean and air freight, ground freight, brokerage, and contract logistics, in addition to our more familiar ground package services. Our global logistics network, made more intelligent and efficient, has the potential to radically reshape and reinvent economies. That's why we're interested in 3D printing, which could disrupt traditional manufacturing the way that e-commerce has disrupted traditional retail. Certainly, as this new technology becomes more widely available, there will be bumps in the road and hurdles to overcome. But the power of 3D printing cannot be overstated. It's disruptive not just because it's new, but because it helps small businesses and entrepreneurs do what they already need to do today, only better and less expensively. Therefore, as 3D printing revolutionizes manufacturing, it will also affect our business of supply chains and eventually product pricing and the end consumer experience. 3D printing effectively means that businesses no longer will face minimum quantities. They'll be able to order what they need when they need it. Upfront tooling costs, which is a big expense for businesses both large and small, makes 3D printing ideal for small batch production runs. And there's no tax on complexity. And what I mean by that is there's no corresponding increase in cost for a more complex design like this. The disruptive nature of 3D printing, therefore, will create opportunities, but it will also require adjustments. As it becomes possible to send product design instructions via the internet and print products locally, small businesses and entrepreneurs will be able to move from the idea phase to the production phase more quickly and cost effectively. Instead of delivering a product from a warehouse, products could be delivered from a 3D printing service offered at a retail outlet, such as a UPS store, or right to your door. Disruptive technology like 3D printing stands to help our customers do more with a lower environmental impact, all while benefiting consumers like you and me. It has the potential to increase profit margins within the supply chain by reducing cost, and that's good news for small businesses and entrepreneurs especially. Additionally, it's important to understand that disruption will happen. There's almost no stopping the spread of technology and innovation, so we're either in the game or watching it, and I know what side of the equation UPS wants to be on. And to that end, in anticipation of 3D printing's impact, UPS has already started putting 3D printers in the UPS store locations. Our initial customer response was so positive that we have since expanded to more than 60 stores with plans for continued growth. Likewise, through our internal venture capital arm, we invested in a 3D printing manufacturer named Cloud DDM and put their production facilities in the heart of our Louisville supply chain campus, just minutes from our global air hub. The operation has been up and running for a year and allows companies to order parts and prototypes to be printed late into the evening and have them delivered anywhere in the U.S. by the next morning. In doing so, UPS has helped to create a model that actually increases package demand and differentiates the company from other carriers. Now that's groundbreaking stuff. Today, UPS is learning and adapting to new technologies, something we've done many times over our more than 100 years of operation. As proven over and over throughout history, those who embrace innovation and change early and often are the most richly rewarded. And disruptive technology, like 3D printing, has that incredible potential. I commend the committee for their interest in understanding more about 3D printing and welcome this opportunity to share what we have learned up to this time. Thank you for your time today, and I look forward to answering questions.
And Chair, thanks, gentlemen. Mr. Morris, you're recognized for 5 minutes to summarize your opening statement, please.
Well, good morning, Chairman Burgess, Vice Chairman Lance, Ranking Member Schakowsky, and members and staff of the committee. My name is Ed Morris. I'm the Vice President and Director for America Makes, the National Ad Manufacturing Innovation Institute, and we are consciously dual-branded as America Makes, the National Ad Manufacturing Innovation Institute. The maker community wants to deal with America Makes. The deep industry are happy to deal with industries, but the maker community get a little leery of institutes, too formal, too official. So that's the reason for the dual branding. We're operated by the National Center for Defense Manufacturing and Machining, a not-for-profit 501c3 company that's been in existence for over 14 years, solving technical, manufacturing, and business problems for our clients. Our mission at America Makes begins with why do we exist? And as we all know, the U.S. manufacturing economy, the economic engine of manufacturing, is nowhere near as robust as it has historically been or needs to be. So what are we going to do about that? We are taking this incredible technology of additive manufacturing and accelerating it in the United States by dealing with the technical issues, the technical barriers, doing technology transition to companies for real products, new companies, et cetera, and then training the next generation workforce and reinvigorating the interest in the youth of America in manufacturing as a well-paid, excellent career. Why additive manufacturing? As has been shared, it's a disruptive game changer, and game changer is often overused, but I'm comfortable with declaring that additive manufacturing absolutely is a game changer, fundamentally because when you change the game, you change the rules, and this has a whole new set of rules. We have a lot of people come to us and talk about the excitement and their interest in additive manufacturing, and they say, Ed, I want to get involved in additive manufacturing. ASTM has identified 7 different types of additive manufacturing, and I realize when people approach us, they're generally, it's like asking me, you know, hey, Ed, I want to cook dinner. Help me cook dinner. And to be more specific, what heat source are you going to be using, lasers, et cetera? What materials are you going to be using? Are you going to be using polymers or plastics? Are you going to be using metals? Are you going to be using ceramics? Are you going to be using organic tissue? And are you going to be using human tissue? And then what are you going to do with it? What's for dinner? Are you going to be serving plastic parts, mechanical parts, electronic parts? Food. One of our 3D Systems did a demonstration of printing Oreo cookies for a demonstration that we were involved with. And you can print body parts. One of the things that excites me is the potential of integrated mechanical and electronic 3D printing devices. And one of our key members, the University of Texas at El Paso, with the Keck Center for 3D Innovation, we've recognized them as our first satellite center, broadening our footprint in a very substantial way across the United States. Our public partners in this adventure are the Department of Defense, the Department of Energy, the Department of Commerce, Department of Education, NASA, the National Science Foundation, the FAA, and the FDA. And we are strong believers in the power and wisdom of a public-private partnership. We currently have 163 members. In correcting an error in the printed testimony, we have 55 small business, not 85, 43 large businesses, 13 government partners, 10 nonprofit organizations, and 4 manufacturing extension partners, or MEPs. And they are a very valuable partner in helping doing the technology transition for this. As of January 2016, we had an $87 million portfolio of research and development sample projects. Our use of additive manufacturing in the foundry business, led by Youngstown Business Incubator, revolutionizing the foundry casting business, making sure it stays on shore, taking out cost, cycle time, and improving product performance. We also have a project on biomedical devices with the University of Pittsburgh, working on optimizing a magnesium alloy for bioreabsorbable cranial implants. Applying the partnership model to education, we are doing lots of activities, including a certification program with the Society of Manufacturing Engineering, a fellowship program with the American Society of Mechanical Engineering. We're partnering with the U.S. Department of Veteran Affairs as part of a Google Google.org grant to train returning military veterans. We think that's a very important service to the nation. We're a better source of expertise and competency to tap, and innovative people as well. And then we're also revolutionizing STEM education for those that want hands-on learning, making math relevant in what you produce with the capabilities. Regarding the public-private partnership, its ability to, with cost share as the economic model, we think it's a very wise policy and business practice. The taxpayers' investment on topics of mutual interest is that we're able to almost double the taxpayers' money. The industry side is able to maximize their research and development dollars, so it really is in line with the better buying power vision of the Department of Defense to optimize contractor research and development and internal research and development. And then finally, in closing, quoting a good friend, Steve Welby, the Honorable Secretary of Defense for Research and Engineering, with this technology, let's disrupt ourselves before others disrupt us. Thank you.
Chair, thanks, gentlemen. Dr. Herderick, you're recognized for 5 minutes to summarize your opening statement, please.
Thank you. Chairman Burgess, Vice Chairman Lance, Ranking Member Schakowsky, and members of the committee, it is a privilege to share GE's thoughts on 3D printing, which represents a larger digital industrial revolution happening in the U.S. and globally. Today, a designer can create a computer-aided design model of a part and digitally transmit it to a 3D printer to be directly manufactured. Increasingly, new designs and processes like this are being connected and managed through a digital thread where the freedom of design and manufacturing seemingly has no limits. One of GE's engineering leaders appropriately captured it when she said, "Complexity is free." My name is Dr. Ed Herderick, and I am the Additive Technologies Leader for GE, helping to spread the application of additive technologies across GE's industrial portfolio. This portfolio spans across industries that build, move, power, transport, and cure the world, from jet engines and power generation machines to locomotives, medical imaging systems, and more. The emergence of 3D printing and additive technologies in industry has been both sudden and disruptive. Recently, Boeing and Airbus conducted the first flight test for their 737 MAX airplane and A320neo single-aisle jets with GE LEAP engines. LEAP is the world's first jet engine to include 3D printed fuel nozzles, one of which I have here on the table, which is the engine's fuel injector, mixing fuel and air in precise ways to achieve maximum fuel efficiency and lower emissions. Using metal printing, the fuel nozzles are more fuel efficient, lighter weight, and more durable compared to those made with conventional technologies. The production of 3D printed metal parts in jet engines would have been almost unheard of even a decade ago. Today, we are asking what else can be printed in the engine to drive performance even higher. As it is, GE Aviation will be producing 35,000 printed fuel nozzles per year at the world's first mass additive production facility in Auburn, Alabama. By 2020, we will have produced more than 100,000 metal printed fuel nozzles. This success of industrial implementation of additive technology in the aerospace industry is paving the way for broader applications in other industries. GE's use of additive technologies in aviation. Oh no. We okay? Okay. Hopefully my voice was loud enough that you picked it up okay. GE's use of additive technologies in aviation is only the tipping point of an exciting transformation underway across our 400-plus factories. By 2025, we expect additive manufacturing methods will be used in the design and manufacture of more than 20% of GE's new product concepts. Our efforts in additive are part of a much broader initiative to build a digital thread through manufacturing that transform our factories into brilliant factories. It is through the digital thread where additive technologies can truly emerge and realize their full potential for industries of all kinds. Let's see. In many ways, the excitement and emphasis on additive manufacturing of metals and industrial materials is the product of a more than 20-year research odyssey. As early as 1993, researchers at GE Global Research demonstrated the feasibility for binderless sintering of metal powders. It's interesting to note the development and material advancement between then and now. In 1993, the laser used had only 7.5 watts of power, a scanning speed of 2 millimeters per second, and produced parts that were 30% dense. Today, we are using lasers with 200 to 1,000 watts of power, scanning speeds of 1,000 millimeters per second, and produce parts that are greater than 99.9% dense straight out of the box. Further, when implemented with care, the performance of additively produced metal parts today meets and even exceeds that of standard casting techniques, and this is a critical point. I cannot emphasize enough the importance of understanding the physical metallurgy in order to produce this high-quality, repeatable performance as the materials properties are determined during the printing process. Manufacturers have had centuries to understand the physical properties of materials that have been traditionally milled or machined into the desired shape with additive and mirrors. Fortunately, GE, through its Global Research Center, is home to some of the world's foremost experts in materials and additive techniques to help us make these evaluations. I'd like to highlight a particular example where GE printed a miniaturized version of a steam turbine rotor to test a new idea GE researchers have for reducing the cost of water desalination. The rotor, roughly 6 inches long, is being used to demonstrate cost-effective water and salt separation. In that case, metal printing empowered the team to design something that could not be made in any other way and has the potential to dramatically improve the energy efficiency for this critical water desalination process. In order to accelerate new applications like this one, GE has built a new facility in Pittsburgh, Pennsylvania, dedicated solely to 3D printing called the Center for Additive Technology Advancement. And that was an ARPA-E program and partnership. I'd like to highlight, let me see. So I'd like to highlight some of our work and the critical importance of building a robust ecosystem in additive technologies across the U.S. We're proud to be a partner of and applaud the America Makes National Additive Manufacturing Innovation Institute in Youngstown, Ohio, which has been a leader in building this ecosystem of manufacturers, machine makers, and other key stakeholders in the additive supply chain. As we go forward, GE will continue to look for ways to strengthen the additive ecosystem here in the U.S. In closing, additive manufacturing is a transformative technology that is opening up new frontiers and is an important tool in realizing GE's brilliant factory vision. It is and will have far-reaching impacts that accelerate the introduction of new high-performance products that will support global infrastructure for years to come. Thank you, and I look forward to your questions.
And Chair, thanks to gentlemen. Thanks all of our witnesses for your compelling testimony this morning. Thanks for all you're doing for the revitalization for manufacturing in America, and we appreciate your efforts in that regard. Dr. Herdrich, I just, you talked about the experience you've had with manufacturing things for years, and now you've moved into this new realm. So I suspect there were significant challenges for like the quality control folks who assured that the device in question was going to stand up under the heat and pressure of a jet engine or a pump or whatever you were building. I suspect that has been an ongoing process and one that has developed sort of simultaneously with the technology. Is that a correct assumption?
It is. Yeah, so it's been a many-year journey, and I think what GE brings to this is our knowledge of commercializing other advanced technologies like advanced casting techniques, welding techniques, and the like. And so we use the same process methodology of really fundamentally understanding the science at our research center, as I mentioned, and then working closely with our partners to really understand how these products perform in the field.
But you're literally building airplane parts out of pixie dust and putting them in the planes that we're all going to fly home later today.
Well, it's advanced metal powder that looks like metal flour, so I suppose you could paraphrase to call it pixie dust, but it's very highly engineered pixie dust.
That is reassuring. Mr. Oringer, let me just ask you, your technology, you talked about it in your testimony, invented your company in the United States, patent system in the United States, despite challenges, is one that is the envy of the world. But then you intersect with the regulatory side of the world, so sometimes we things that are invented here, but then subsequent manufacturing tends to go other places in the world. So is that something that you all...
You're absolutely right. So as I said, this technology has been around for 30 years. We've invented close...
extent possible, we want to remove barriers for you. We don't want the manufacturing, we don't want the invention to happen here and then the manufacturing occur somewhere else. We want these jobs in the United States of America. We want to make America great again. Can I say it any more succinctly?
I'm not going to touch that. Yeah. I will say to that point, I very much appreciate that. And I will say that what's actually been quite exciting coming over, I spent most of my career in the federal government and only have transitioned to the private sector in 2 years ago. And I'll tell you, coming to this company and seeing what we're doing in terms of U.S. jobs is phenomenal. We just acquired 2 European companies, a French company and a Belgian company. These are companies that have been honing the craft of metal additive manufacturing. And we're now seeing an insourcing, thanks to my company, not only in terms of production, but R&D. We're actually moving these jobs over here, and it's actually thanks in part to projects that we're doing with America Makes. I'm actually funding a aerospace and defense project. We've started to build up a laboratory in Penn State, and it's thanks to the good work of Ed and his colleagues, as well as other folks that we're teamed with, that's seeing this technology not sit still, but continue to innovate. And we will certainly stay engaged with you as we navigate these waters.
And I appreciate that. You're two of the most highly regulated industries, medicine, healthcare, and the aerospace industry. So, Mr. Morris, did you want to add something?
Yes, in regard to the global economic competition we find ourselves in, it is absolutely true that although the technology of ad manufacturing was invented in the United States, we lost the lead. And generally, the sense is that Europeans are ahead by about 5 years because they doubled down with national investments in their areas. And they are the major source of the materials and the 3D printing devices, although in the United States and companies such as 3D Systems are coming on very rapidly and regaining the lead for the United States, which we think is crucial. I think this really comes into focus the importance of a public-private partnership as a wise policy for a nation in this global economic competition we find ourselves. And it's a good business model for the taxpayer and for the companies and academics, for that matter.
Very well. Chair, thanks, gentlemen. My time's expired. I recognize the ranking member of the subcommittee, Mr. Kowski of Illinois, for 5 minutes for questions, please.
Thank you, Mr. Chairman. I encountered 3D printing in 2013 we had a manufacturing showcase, and Congressman John Sarbanes brought in a business from his district, Direct Dimensions, and they took a picture of me, 3 or 4, and made this 3D print, a bust of me in plastic. It was very interesting and a little strange, but I did save it. I want to say this is part of our series, as I'm sure our chairman said, of our Disruptor series. And what we're hearing today are the wonders of this and the positive. And I just want to say before I ask questions along those lines that these technologies can be in the hands of all kinds of people as we go forward. And I hope, Mr. Chairman, that we'll also have a hearing on what are the things that we ought to watch out for. I know that Congresswoman Clark raised the issue of the ability to produce perhaps small arms, but who knows? And so I think we ought to be looking ahead, too, and thinking about if there are threats to our country because of these kinds of new technologies and in the wrong hands, not only through our concerns about competition around the world and making sure that we can advance making in America, but actual threats. But I wanted to focus on the positive at Northwestern University, which is in my district in Evanston, Illinois. They are researchers are pioneering biocompatible inks made of graphene that are used to 3D print scaffolding for tissue transplants and regeneration. Very exciting. These graphene structures can stimulate cell regeneration and also are cost effective. So, Mr. Oranger, could these kinds of cutting-edge treatments become more widely accessible through the use of 3D printers?
Yes, actually, I just returned from your district. I was just there last week, talking to a couple of folks about Northwestern's interest in metal. And I'll tell you, the Chicago area is booming in this area, very competitive area for this technology. And it's very important that we continue to innovate there and incubate that technology. On the bio side, I'll tell you, there's a lot of fact and fiction and aspiration. To answer your question, I think you summed it up quite well. There is sort of the short term, there's a lot that can be done in scaffolding, and it's being done currently, and I'd say we're about 1 to 2 years away from seeing this matured sufficiently where it's going to become as commonplace as some of the other methodologies I discussed. On the other side, our folks in our medical modeling department indicated that we're still a few years away from actually seeing a viable process for some of the other bioprintable inks. But the research is being done. We do see a feasible path forward. We are watching a lot happen in this marketplace. There are a lot of exciting new companies that are coming online in this space. And we would encourage that technology continue to flourish, and that the government itself has a role to play. We've been talking to NIH about this particular issue to see if there are ways we can work with them in terms of spurring innovation in this area.
So you indicated some fairly early benefits here too. So at what point do you think we will be able to see real savings for patients? And are we doing what we need to do now to make that occur?
Well, as I highlighted in my opening statement, 3D printing has long been providing strong value to patients, not only in the hearing aids, where we're making 99.5% hearing aids through 3D printing or Invisalign, but in the medical modeling and in the implant process as well. It's literally saving lives. We were talking about this earlier before the hearing. We've seen estimates that it takes about, we charge patients about $100 a minute in the operating theater. So if you can reduce that time by rehearsal, by using CT scans, 3D printing the model, and then practicing that surgery over and over again, and then also 3D printing surgical guides, which are essentially stencils that you place on a patient, and reducing the amount of improvisation to zero, then you're literally going to be saving lives, enhancing precision, and saving money. And so I can tell you that we have done tens of thousands of these procedures, and we're seeing a lot of breakthroughs. In terms of the scaffolding, there's a lot of investment in this arena right now. There's a lot of promise, and I could tell you that, and the government's well involved as well, not only from the NIH, but in the Department of Defense, the United States Navy, Walter Reed National Medical Center. There's a lot of work being done here, and I think we're not too far away from some active clinical trials.
Right. Maybe in another round, I could ask Mr. Morris how America works in this health space. Thank you.
Gentlelady yields back. Chair thanks the gentlelady. Recognizes the gentleman from Kentucky, Mr. Guthrie. 5 minutes for questions, please.
Thank you very much. It is great to have everybody here. What an interesting series we've had in this. I really grasped technology when I was in grad school in the mid-'90s, not even that long ago. And it just really disrupted the typewriter and the calculator industry, because we just got to do what we did the same thing that they were already doing, just did it more efficient. I think also disrupted the whiteout industry when I got to go on a word processor. I didn't have to use it anymore. But it really just already took what we were doing and just made it better. And what's happening now is you're actually taking this technology and just doing things we could never do before. It was amazing in the body parts and the replacement. You couldn't do those vertebra probably in any other type of manufacturing. I have a manufacturing background, and we take blocks of steel and make dies out of it. We whittle it down, for lack of a better term. That's actually what we do, just with computer-controlled machines. But now creating stuff by printing it, by being additive, is just, I hope it doesn't replace what we do, but it certainly enhances to precision what you can do in specific things. So it's fascinating to be here. I'm going to focus with UPS. UPS is just outside, their Warport's just outside of my district, but a lot of your employees and a lot of your customers are in my district. Zappos Shoes, BestBuy.com, and Geek Squad, which is a pretty interesting place to go. They don't have a plant manager, they have a mayor, and they don't have community leaders, they have ambassadors, so it's just an interesting business concept, but great people to be around. But a lot of it's based on supply chain. I know a lot of us think of UPS as and you said it in kind of your opening statement, the brown trucks in the airplanes that are flying in and out of Louisville. But I know I'm more interested in what UPS really does. And you talked about it a little bit. Just give you some time to elaborate on how UPS actually helps small businesses with supply chain management to build their businesses, and how 3D printing is a big part of that mission.
Yeah, thank you very much. So UPS is more than a package delivery company. We're a network company. We're not a manufacturer, but we're a network company. We're a problem solver. And so we see 3D printing as another tool in the bag to make businesses more efficient and to help them expand. So That's what the small businesses is what the UPS store is all about, and helping small businesses grow. So when we put 3D printers in the UPS stores, one of the things small businesses have to do if they have a new product idea is to design a prototype. Prior to 3D printing, that's an arduous task, right? You've got to create a model. Sometimes that model is produced outside of the outside of the U.S. and shipped back. Now we're giving them the opportunity to produce that model and do rapid prototyping right in their home city. I have an example of a gentleman that we highlighted during our 3D printing week named Caleb Kraft. And what he did was he's creating supplements to gaming controls so people with disabilities can play the game. And because people have different disabilities, everyone is different. Can you imagine how difficult that would be before 3D printing? That's one of the things we're unleashing innovation. And so that's the small customers. We're seeing a lot of hobbyists, small businesses, and designers using the UPS stores. We have now more of an industrial grade 3D printing operation in our Louisville supply chain headquarters. And that's being used by designers, but it's also being used by big manufacturers that have these service part networks, and they need to have on-demand parts. And so we're allowing them to order parts from us and be delivered anywhere in the
Okay, I have just about a minute, so I just want to ask you a couple more questions.
Yeah.
But I'll ask them both and then let you answer. So where do you see the most demand for 3D printing today, and where do you see it in 3 to 5 years? And what policies should we consider, what are important for us to consider as you see the demand for 3D printing and where it's going, and what can Congress do to help or not help, or get out of the way, I guess is the right question.
So great. So right now, this is what we're seeing. We're seeing a lot of rapid prototyping. That's kind of the application we're seeing the most. We're also seeing a lot of small batch production runs. So even large manufacturers, if they're only printing or need to produce 500 or 1,000 of a certain item, it's actually less expensive right now to do it via 3D printing, and we're all about efficiency, and that's what they're doing. Now, 5 years out, I wish I had a crystal ball, but what we see is we see more customized products, right, that are tailored to the specific needs of the individual, and 3D printing can allow that to happen. We think that's a little further out, but right now we see the definitely on-demand parts in prototypes. And in terms of legislation, again, UPS is a network. UPS is a global network. Right now, we're only doing 3D printing in the United States. Eventually, just like we've helped businesses by connecting a global network with our transportation, the plan is to do that with 3D printing. And so as that happens, there are going to be legislative issues that arise that will need to be addressed to keep that going, because we know that the more we can promote global commerce and trade, it's good for everybody.
Chair thanks the gentleman. Gentleman yields back. Chair recognizes Ms. Clark from New York. 5 minutes for your questions, please.
I thank you, Mr. Chairman. I think our panelists today, very stimulating conversation. It's great to hear all of the innovation that is taking place, and the sky's the limit as far as I see it. I'd like to focus on access for underrepresented communities. This has been one of the focus issues that I had that are especially important to me. Using the emergent 3D printing industry is a unique means of empowering and including entrepreneurs from underserved and minority communities, because startup costs are lower and flexible, customization is easier, 3D printers offer advantages and opportunities to small businesses and new entrepreneurs entering the market. still huge diversity gaps remain in the technology manufacturing space. So to harness the true potential of 3D printing, I think it's important to commit to eliminating obstacles to sort of equitable and to promoting initiatives that I believe can close this gap. You, Mr. Oranger, spoke about a relationship that was established with Penn State. Want to drill down a little bit and talk about perhaps colleges and universities in the HBCU system and the HSI system and community colleges. And then, Mr. Anlin, you spoke to the small business advantage as well. So, Mr. Morris, my first question goes to you. What kind of outreach does America Makes do to communities that are underrepresented in the tech world, including minority, low-income, and disabled workers?
Thank you. Excellent question. That's one of the key reasons why the University of Texas El Paso was so attracted to us. Not only are they a leader in developing the technology of additive manufacturing, but also in deploying it in their community with a heavy U.S.-Mexican population, economically handicapped. And we want to partner deeper with them to be able to help them continue and expand their technology transitions. Again, more education in that area and spawn new products, et cetera. Tied to that also is the vision that we have of getting printers in every school in the United States. I was certainly taken aback last year when China announced an intent to put 400,000 printers in every one of their elementary schools. We should be doing the same thing and proceeding up the chain for more than just the elementary schools. That's the time to catch the youth in America, get them excited in careers, in making things. And in our context, when we talk about additive manufacturing, it's a system of systems of design, manufacturing, inspection, production, et cetera. So it's all of these different well-paid, good careers, long-term careers that catching the youth in America, no matter where they are, no matter who they are, I think is pivotal for the United States. Is an important step forward.
So can you speak to some of the common challenges that entrepreneurs from underrepresented communities may face when beginning to incorporate 3D printing into their own small businesses?
What we are finding as small companies come into America Makes as members, and we operate as a community of practice, openly sharing. We operate in this middle ground of pre-competitive activities. When the small companies are able to rub shoulders with companies like 3D Systems, Rockwell Collins, Lockheed Martin, Northrop Grumman, et cetera, they develop relationships. So one of our small companies, RP+M in Cleveland, has benefited from that relationship and is now doing contracted work for them. So building this community, and we're very focused on the additive manufacturing supply chain ecosystem. How do we define that? How do we focus it in regional areas? We're doing some pretty incredible things in our region, in Northeast Ohio and in Southwest Pennsylvania, trying to flesh out, define that ecosystem and energize it for all of the communities, and with a focus on those that are most urgently needing that economic boost.
Very well. Mr. Oranger, I saw you nodding a bit there and smiling. Can you want to share your thoughts?
Well, sure. As we were talking about education, I was just reminded when I started working for this company, I came home with a little 3D printer and a 3D scanner. And I have a 5-year-old at home who's more advanced technologically than I am. My wife's a surgeon, so she came home from a long day performing surgery, fell asleep watching TV. My daughter scanned her head, produced a model not too different from that, and she's 5 years old. And I was blown away because I still hadn't figured out how to turn the darn thing on. And if you can see what happens when we bring these things into schools, it's not about 3D printing. 3D printing is a means to an end. Right. And that's something we need to understand. What I think about this in terms of digital literacy. And this is really critically important, particularly in underserved areas. We need to make sure people have a full sense of what it means to be part of the digital economy. So rather than focusing on getting expensive 3D printers into small businesses, what we really should be doing is making sure they have access to the digital tools, different kinds of CAD, computer-aided design technologies, training in this kind of technology. We can find ways to give them access to machines, whether it's through great companies like UPS. We have similar programs. We have a company called Quick Parts that does on-demand printing. You send us the CAD, we'll print out the parts. It's not about getting the 3D printer necessarily to those entrepreneurs. We actually are able to reduce the logistical footprint for folks, and now we're digitizing things. You don't even need to have that. So I think the task is important. I don't think it's as difficult as it could be, and there are institutions like America Makes and others that are doing some, but we need to do more. We've talked a little bit about our outreach to the veterans community. We've done a lot with Walter Reed and the Veterans Affairs Administration. Again, there needs to be more in this space, and we'd love to talk to the committee and figure out ways to catalyze more of this.
Actually, if I may add to that.
Yes,
because this is just briefly.
Sure.
I think you made some great points, and I think what's really exciting about 3D printing is it's just such a transformational educational technology for getting people into manufacturing, and it's really just gotten into the public consciousness. And I was actually with a GE Volunteers group in the Bronx. We did an outreach young entrepreneurs workshop with some students, middle school and junior high school students. And what was amazing was half the students, they were coming up with ideas to 3D print different consumer parts for iPods and things. And when we go out and do these GE Volunteers outreach activities, I'm doing things like taking fuel nozzles, taking manufactured components. We take 3D printers into schools and different workshops and things. So it's this tool to get people hands-on with manufacturing in a way that we couldn't do with casting or welding. So it's really a gateway to get them into these great entrepreneurial fields and these great careers. And it gets me really, really excited.
Very quickly, we do some summer camps. And one particular summer camp was 7 through 10-year-olds. And one of the exercises was to take the students into our little Kiva round hut whiteboard, and they drew cookie cutters. And one minority student drew a nice little figure cookie cutter. He then took it over to the desktop 3D printer and made the cookie cutter. And we got a great picture of him, look, Mom, this is what I thought. This is what I designed. This is what I manufactured. Here's a cookie cutter for you.
The chair thanks the gentlelady. Gentlelady yields back. Chair recognizes the gentleman from New Jersey, Mr. Lance. 5 minutes for your questions, please.
Thank you, Mr. Chairman. A very interesting hearing. Mr. Oranger, balancing health and safety is obviously an important mission for medical device manufacturers and federal regulators alike. What steps are the federal regulators taking in order to educate themselves and the public about 3D printed surgical implants? And has this approach been proactive, and what else, in your judgment, could be done?
Yes, sir. Thank you so much for this question. I have to say, and it's not just because I'm a former federal bureaucrat, we've been actually pretty pleased with the engagement that the Food and Drug Administration and others have shown. They actually held a workshop in October 2014 on their Silver Spring campus. They invited companies not only from the United States but from all over the world to have this dialogue, and it was an all-day affair. The FDA said they were in receiving mode. They wanted to hear what the concerns were from us about regulation, what the concerns were for us in terms of barriers for innovation. Are we any different from any other technology when it comes to regulation? And I think in the end, the conclusion was no. We're one tool in a toolbox. You have digital tools, you have means for designing things, which is the CAD package, and you have different ways for actually executing. So I think one of the challenges we need to stay on top of is folks' attempts to redefine this technology as something that's extraordinarily different. We're not making Star Trek replicators here. These are very important tools. They have their usage. They also have their limits. One of the things I sort of alluded to in my statement, though, was concern about the inability for the pay codes to keep pace with innovation. So right now, we're innovating, doing unique surgical processes We're saving a lot of money for the health system overall, but the truth is there are no insurance pay codes that can tell the patient this is how much it really costs. So what's actually happening is we're saving money, but the insurance companies, whether it's Medicaid, Medicare, or private insurance, don't have a means to code what that procedure is. And so there's actually a bit of a margin here. And we would love to engage the folks at CMS, Medicare, Medicaid, or others to ensure that we're actually able to make a fair process and bring that up to standard. Because right now, as you know, sometimes government regulation is a little slow. Sometimes standards can be a little slow to implement. We really need to get this right because we're not really realizing all the potential.
I trust those at Medicare and Medicaid and CMS will be monitoring this hearing because obviously we need those codes for the reasons you have suggested. Mr. Morris, you wish to comment?
I personally attended that workshop by FDA in 2014, and I found it intriguing. My background is aerospace and defense, and as I was sitting through the different presentations on the medical applications, I found myself about two-thirds away through the first of a two-day event. I was getting bored. Why would I be getting bored? The problems and issues that they were all addressing are ubiquitous in manufacturing. Need better materials properties, need better inspection capabilities, need better design tools, etc. At the end of the 2 days, my personal synthesis was there are basically two differences in medical applications from all the different things like what they're doing in GE. Sterilization and body biocompatibility. The common problems makes the importance of an institute focused on additive manufacturing and be able to share across business sectors really relevant. So we were very pleased when the FDA actually became a signed member about a month ago, so they can sweep up the things we're already learning, hear their specific needs, and advance all of the technology across the United States.
To the distinguished members of the panel, are we in the advance in this country, or do other countries, perhaps in Europe or Asia, have a system that recognizes this to a greater extent than we do in this country?
It's been interesting in that one of the things that I heard from a good friend, Terry Wallers, one of our members for Wallers Associates, he did some visits at the invitation of Chinese government a couple years ago, and they shared that they're doubling down on their national investments in additive manufacturing because they saw what the United States was doing. So they're now surpassing us. Representative from Singapore visited me personally in Youngstown, Ohio, in our facility at downtown Youngstown. And they have now stood up a Center for 3D Printing and Innovation in Singapore with an initial funding of $150 million, more than twice the funding I have.
Thank you. My time has expired, but I hope to be able to pursue this further in the future. Thank you, Mr. Chairman.
Chair thanks the gentleman. Gentleman yields back. Chair recognizes the gentleman from California, Mr. Cardenas, for 5 minutes for your questions, please.
Thank you very much for imparting your knowledge with us on what's going on in this dynamic, fast changing industry. First question is from my wife. When do you think that they'll be able to make a husband's brain? I didn't say a human brain. I said a husband's brain to help someone pick up after oneself, remember anniversaries, etc. Just kidding, just kidding. That's the impossible, I know. But now, on a more serious note, we've noticed that in America's libraries, we've had an increase of donations and opportunities where libraries are investing in 3D printers. Now to the tune of over 400 libraries have access to little to no cost, or no cost, to individuals going to the library. To me, this is a very important issue for making sure that we have access to as many minds and as many inquisitive folks so that they can get turned on to how wonderful it is and how the potential of getting a job in the industry. How committed is the industry to advancing that kind of effort?
Well, I can take a shot at this just because we had a little bit of a excess inventory of desktop 3D printers about a year and a half ago. And we didn't rehearse this, by the way, just so. And I had this great idea. Why don't we donate these printers to libraries across the country with one hitch? I didn't want to donate a couple hundred printers to libraries and have them just sit on a shelf and collect dust. And that's a really big problem, I see. So we actually held a competition. We partnered with America Makes because they know how to do competitions, and had an overwhelming response from all across the country. We need to do more like this. It's going to pay back dividends. We're struggling certainly still in terms of workforce development, in terms of making sure people have access to this technology. And I strongly believe that if we can start bringing these kinds of tools to young people as soon as possible, that's going to pay dividends in the long run. So we're strongly committed. I know other folks on this panel are as well, and we'll be happy to keep you informed on our progress.
Yes, that's an investment in human capital and in connecting your industry to the minds of the workers of the future. Yes? Mr.
We
Morris?
pay a lot of attention to unintended consequences in what we do. You can do something really admirable, and at the end of the day, you were not doing something so admirable. So even with the vision of a printer in every school, we are urgently needing encouragement at all levels of the government, beginning at the local communities and perhaps in some of the local rotaries, et cetera, so foundations and groups that are able to provide some funding. For example, if we put a 3D printer in Miss Brown's class and it breaks, who's going to fix it?
Mm-hmm.
Who's going to buy the materials? Miss Brown? That's not very kind. And for the libraries, same vignette.
Mm-hmm.
How we keep it operating, how do we get the training materials in all the libraries, in all the schools, how do we have the resources made available so it's not burdensome when this thing shows up? You can do great things in the nation, but we have to do it wisely.
Yes, thank you for pointing that out. One of the things that I'm so proud to be an American is the fact that we have this reputation that when we embark on something and we dedicate ourselves to doing it well, it takes a long-term vision and a long-term commitment. And there's infrastructure costs, there's ongoing costs, et cetera, instead of just the flash of, for example, the ribbon cutting, giving away printers, and then coming back a year later and embarrassingly realize that none of them are in use because you just explained that without the follow-through, they're not doing anybody any good.
Right.
And it's a falsehood for whenever any of us, whether it's government or private industry or philanthropically, we do something without looking at the long sight of the issue. So thank you for pointing that out. But on the follow-up on that is I hope that you read into my question that not just libraries, public schools, et cetera, that the industry actually maps out and shows us how we can either partner or they can take the lead, et cetera, and how we can make sure that we have that available as much as possible to every community in America. Again, it's an investment in human capital, I think. I want to point out with my limited time here that when it comes to bioprinting, apparently when you look at the 3D printer is used to place bioink in precise locations, allowing cell types to align themselves in a manner that resembles the origination of native human tissues. These 3D human tissues can then be employed in drug discovery and development, biological research, and therapeutic implants for the treatment of damaged and degenerating tissues and organs, et cetera. You get the picture. This is amazing. What do you see the top line issues facing those efforts when it comes to regulatory and technology and world competition?
I'm not competent to just address the regulatory
Okay.
issues, but what I will say is I think where a National Manufacturing Innovation Institute can come to play in a very important way in advancing bioprinting, as we do with all the other areas of application of additive manufacturing, is getting from the research to the true product application. There's historically what's called the valley of death. And we've got a structure to cross that valley of death. It begins with pulling a community of the researchers, academics, labs, et cetera, across the nation with the end users and start that discourse of what do you need, where are you going, what are you building, how can we apply it, how can we accelerate it. And so we do a lot of workshops to do road mapping, and we would eagerly like to do road mapping with bioprinting. We have several of our members are doing some landmark research and development in bioprinting, such as University of Pittsburgh, Case Western University, et cetera, team those up with the medical end users, working with our new member FDA, et cetera, to lay out what's the right path, how do we accelerate, what's the funding model, and then continue to go back to this model of the opportunity to do the key thing in a public-private partnership, and that is share the cost. Where it's high risk, government money comes into play. Industry needs to invest because they're doing the product application. We think that's a very shrewd model going forward, a public-private partnership with cost share, which is unique capability of an Additive Manufacturing Innovation Institute.
Thank you, Mr. Chairman. I yield back.
Chair thanks the gentleman. Gentleman yields back. Chair recognizes the gentlelady from Indiana. Ms. Brooks, 5 minutes for your questions, please.
Thank you, Mr. Chairman, and thank you all to our panelists for your actually exciting testimony. I wasn't sure when I was reading this initially, but I think why this is so exciting is because I think this is the way to draw young people back into manufacturing.
Absolutely.
We have in central Indiana, in my district, about 50 middle and high schools that have 3D printers that are being utilized in the classroom. We're trying, Indiana's one of the country's most manufacturing intensive states. But, and then before coming to Congress, I was senior vice president at our state's community college, and where, you know, I learned about 3D printing during that time period. But I think we still need to make sure that the adults and the educators who are working with our young people have an understanding about this 3D printing. I had an event, and we welcomed 3D parts manufacturing to educate school counselors at a school counselor event to try to educate them about 3D printing, because they're the ones who influence our children and get them excited about these things. So I'm curious, in expanding on the public-private partnerships, which I completely believe in, how do we do a better job bringing industry, collaborating with our educators, and with either our nonprofits, and try and get the young people more engaged in 3D printing and in the skills that they need? What are some best practices you've seen? How do we expand this? Because I think it is one of the manufacturing tools of the future. What do we need to be doing better? And believe it or not, I actually think calling the where they work maker spaces actually helps.
Absolutely.
Because young people are not as interested in manufacturing, I think, as they are in making. Mr. Morris, you want to start?
I'm wrestling with jeopardizing and putting at risk a very important relationship we have with Elizabeth Forward School District outside of Pittsburgh, Pennsylvania, Elizabeth Forward. They are a premier benchmark of redefining education in the United States and leveraging the power of additive manufacturing 3D printing to teach. The risk in the friendship is they are already being inundated with people that want to know what they're doing.
Oh.
It's the right place to go. So we need to find some way to assist them, and the key thing at this point is communication. We could use more resources to communicate better across the nation. This is what's happening. This is how you do it. This is where we can work together in that public-private partnership model to, in very interesting terms, infect the United States with manufacturing is back, and it's the right place for careers.
But if you think about, so Dr. Herderick, the GE is located in so many locations across the country. UPS obviously is. I don't know that your company is yet, but I mean, what do you view as industry's role in partnering with the education community? And I welcome the fact that you put them into libraries and so forth. But what should we be doing that we're not doing?
So I guess I want to, at the risk of contradicting myself, I want to make sure we distinguish a little bit. When Ed did this a little bit already, but there is a distinction between what we see in maker spaces and what we see on a factory floor, and particularly when we get into some of the very hardline manufacturing industries such as aerospace and defense and others. And I really think it's important that we embrace both cultures and drive innovation in both areas. So there's a great company that I work with in Indiana called Third Dimension. They have a beautiful shop of many metal 3D printers They have a whole host of aerospace and defense customers. They are tied to Purdue. They're not too far away from Purdue, actually. And they embrace, and they're a small business, but they're embracing a whole host of fellowships and internships, getting folks excited, not just about the usual maker kind of space where you maybe play around with tchotchkes and toys, but these massive $1 million hunks of hardware to actually see what actually happens on a shop floor and how we're revolutionizing manufacturing, which is a totally different concept. It's really important that you see both sides of the spectrum. Maybe you could see the maker spaces as a gateway, but if you don't bring in the other part of the equation, then you're missing it. Because additive manufacturing is a serious business. We're a global company. We're the largest. We're in 50 locations all over the world. People haven't really heard of us, and there's probably a reason for that. The reason is, until recently, GE wouldn't want to brag that they used additive manufacturing because they didn't want their competition to know how they made the secret sauce, and that still takes place. Our first additive manufacturing machine, the serial number is SLA3. I saw it a couple years ago in General Motors. It was installed there in 1989. This is not a new industry. It's just new to people who are suddenly. So I think the makerspace concept is great because it's suddenly captured people's imaginations. But it's also important when you think about public-private partnerships, encouraging manufacturing, that you also bring people into the fold and understand that this is also revolutionizing manufacturing now.
Thank you. Thank you, my time.
Gentlelady yields back.
Fired.
Chair thanks the gentlelady and recognizes the gentleman from Mississippi, Mr. Harper. 5 minutes for your questions, please.
Thank you, Mr. Chairman, and thanks to each of you. It's an amazing technology, and we really are just only beginning to see what all we're going to be able to do in the future. And Mr. Amling, I don't have a question, but certainly welcome you. UPS was my very first job in my life. As a 15-year-old, I loaded an 18-wheeler every night with boxes, and I'm the one who packs the trunk on the family trips. We know how to
learn to work hard.
We know how to build the wall.
Bend at the knees, right?
That's it. And it might have been a 3D component to that as well, I'm thinking. So, but thank you each for being here. Dr. Herdrick, when GE obtained certification from the FAA for its LEAP jet engines, it was clearly a major accomplishment for additive manufacturing. Just curious, how many pages of testing data does a company need to rely on in order to obtain that FAA certification for a new item like that?
I mean, so our materials testing database that we build up before we take it to the FAA, I mean, it's many hundreds, even thousands of pages. I mean, it represents over a 10-year journey from initial concept. I mean, it was a single engineer. She had an idea in our combustors group for the fuel nozzle, looking at machines, and then, of course, it became a cast of many hundreds. Yeah. And so it was a pretty serious book of knowledge that we took to the FAA, as you might imagine.
It's amazing. I'm just curious, what extra effort was needed to show that the nozzles, which was entirely 3D printed, that they were strong enough and did not create a safety risk? How do you go about that?
So it all starts with understanding the fundamentals of the process and demonstrating what we would call a stable process. So demonstrating over many, many thousands of cycles. It's not just building one and going out and testing it. It's many years of effort and building many thousands of fuel nozzles and demonstrating that every one is the same coming out of the machine process. We do post-treatments to heal any defects that come out of the machining process, and then we actually x-ray the parts before they go out into service. So each part, we have a 3D image of the part before it goes onto any engine.
And of course, going through this process, did this help GE learn how to navigate this certification process so that future parts maybe experience a quicker process?
It did.
Okay, that's great. How does additive manufacturing fit with and add value to the traditional supply chain? Explain that to me a little better.
Yeah, it's a great question. So I'll talk about the metals technology. So I think a lot of people look at these metal printing technologies and think, you know, maybe this could replace casting or replace forging. In reality, what we're using it for is to create more valuable, higher performance products during the design phase that then transition to castings and forging. So really what it's doing is opening up some highly value added applications, which really truly fit with American manufacturing, you know, high value, complex shapes and parts that we wouldn't be able to design without having the metal prototyping processes during our testing phase.
Great, that's great. Let's talk about cost for a minute. What kind of cost savings do you think could be achieved if a manufacturer is able to take full advantage of 3D printing and integrate it as fully as possible into supply chain?
Well, I think the biggest cost is time to market. So being able to get to market much, much more quickly and reducing the cost of different iterations of product lines. That's really where we're seeing the biggest benefit, getting to market faster with higher performance products.
Got it. Mr. Oranger, what method of printing was used to produce the titanium hip implant, and why was this the method best for the implant?
Yeah, so this is the part we were talking about here. And you can see it's pretty porous. We use a process called, well, we call it direct metal printing. It's powder bed laser fusion, which is kind of a mouthful. The reason why it's so important, I actually had to check with my wife, who's a surgeon, to actually understand fully what we're talking about here. So typically when you make a part like this, it's going to be casted, and you can ultimately cast a pretty solid and dense part. That's going to cause, when you're talking about titanium, stress on a bone. What we're able to do with 3D printing is we're able to actually design a part that is optimized to both reduce stress on the bone and also be porous enough to get bone to actually grow and actually regenerate. And this can only be done through this process. Typically what they've done in the past is they'll cast this component and they'll have a coating on top that's porous, but it's not, it's relatively superficial. If you can get a densely made part that's also porous, as contradictory as that sounds, you can actually help regenerate bone and help with the growth and not lead to bone stress. And
so this is not only going to be better for that area, but also speed up the healing process.
Exactly.
Really. Okay.
Exactly. And we're actually seeing this area explode. This is part of the factory of the future.
Great. Well, look, I want to say thanks to each of you for being here. I'm over my time. Yield back, even though I don't have any time, Mr. Chairman.
Yeah, gentleman yields back. Chair thanks the gentleman and recognizes the ranking member of the subcommittee, Sikowski, for redirection.
Mr. Morris, I had just wanted to ask you a question on how America Makes work in the health space has the ability to translate into increased access for patients across the country to the advancements that 3D technology has helped to do.
I'm sorry, I'm not sure I heard everything there.
Well, I'm just interested in your work in the health space and how that is going to advance patients' access to better health care.
We've got a couple of projects underway, and several of our members are deeply involved in medical applications of 3D printing. Again, the challenge is to get the word out and across the nation in effective ways, so we try to do that communication as best we can. And there's some interesting things that we've been learning in the process, both in terms of the technology of how you do the inspections and the similarity of problems for making parts for a jet engine versus parts that would be embedded in a body. And then some of the more subtle things, and this is really cross-cutting more than medical. What you heard in some of the testimony from Neil was the models that were made. So a major use of the technique of manufacturing is for tooling. to be able to do tooling to adopt the surgery and to very carefully and precisely guide the surgery tools, etc. And then there's some interesting subtleties. One of the key pieces of technology that's come along with 3D printing was 3D scanning. And as I was engaged with a conversation with a research scientist in the medical community, you know, obviously when you've got a piece of bone missing, maybe from a car accident, maybe it's a wounded soldier, and you want to do a 3D scan so that that implant perfectly fits. And this is where that bioreabsorbable piece comes into play. As the bone grows back, the body absorbs the implant, and you don't have to remove the metal implant, which is really clever. And they pointed out something that was sort of a, aha, boy, I should have seen this one coming. You want it to match, but you also want to match this side of the head, because if you make this one a different shape than this shape, you have cursed that person for life. So there's all these different subtleties that we are communicating with the medical community. It's the explosive use of the technology is incredible. About 1/3 of the patents as of 2 years ago were in the medical applications of 3D printing.
Gentlelady yields back. And Chair thanks the gentlelady. I'll recognize myself for redirection. I mean, you all brought it up, so it's going to come up when we go back home. Our schools are going to ask us, "Hey, how do we get that for our students?" So, any of you want to provide some direction and advice to the members of the subcommittee?
We've initiated 2 years ago a process with Donors Choose, where donors can go to the website and contribute funds and allocate it for 3D printers in their schools, or wherever, maybe a Boy Scout troop, Girl Scout troop, etc. So that is one mechanism for the public to partner in and put their skin in the game, if you will, to get the printers in the hands of the youth of the United States. I want to also quickly point out another really outstanding benchmarking of using additive manufacturing 3D printing for education is US First in the FIRST robotics competitions. Industry has been stepping up in great fashion to tutor and mentor the teams in the FIRST robotics competitions. I personally got involved in this, attending 2 of their annual nationwide and global competitions. And we actually set up, took some 3D printers, and we were doing hospital repair of broken parts in the competition, which was kind of cool. But that's another excellent model of STEM education, training in all of the aspects of design, including business with this technology, and partnering with industry to put up the deep engineering talent, working and mentor the students outside the school.
Very well. Mr. Orridge, I just wanted to ask you, well, you hear the bells go off, so we did have a vote series that was called. Fortunately, looks like we've made it through our hearing, and the good news for you is we've got a long series of votes, so it would keep us away for a while. So I think we'll be able to adjourn before we go and vote. But we do not. This subcommittee does not deal with the FDA, but our full committee does. And it just strikes me as we're talking about things like the templates or the lattice to build new body parts. I mean, this really is cutting edge stuff, and we have a regulatory agency. Yes, they're equipped to tell someone how to go about getting a drug approved. They're equipped to tell someone how to go about getting a device approved. But something that sort of blurs the lines between those two areas may be more difficult. So have you had any experience, positive or negative, in dealing with the regulatory side of this on your medical side?
Yeah, we're actually certified to build class 1, 2, and 3 devices in our facility in Colorado, which is where our medical modeling facility is placed. And our folks there tell me it's a difficult process. It's difficult to be certified to be able to manufacture these kinds of components. You probably want that, though, to ensure that we maintain the appropriate levels of quality, safety, et cetera.
Yeah, I'm going to interrupt for just a second. Yeah, you want it, but you also want the regulatory agency to be able to provide you, or I want the regulatory agency to be able to provide you direction. What are the steps that I've got to go through? What is the pathway to getting this completed? And then the complaint that I will hear frequently is somehow the rules all change along the way, and then I've got to go back and recertify or reapply. That's the sort of, yes, I want the devices to be safe. I don't want to hear about things having to be recalled or removed. It's one thing if it's an automobile, it's a dreadful thing if it's in a child. But we also want to lay out the regulatory pathway for you so that you know, and it's predictable, and you know the steps in the sequence, and you know that when you complete the tasks, that's the end of the process, that it's not an endless back and forth, oh, we're going to need more stuff. We didn't ask you this. We're going to need for you to go back and do this for a couple of years and come back and see us. So that's, when I'm saying that this is your subcommittee too, I mean, that's the sort of feedback that I need to hear, the committee needs to hear, our staff needs to hear. We're anxious to have this be a continuing dialogue because it is, I mean, this is the sort of stuff that's over the horizon, but it's really pretty bright. When I talk to medical students, it's the doctors of the kids in medical school today are going to have tools that no generation of doctors has ever known.
That's right.
That's pretty powerful.
Yeah, I appreciate that. We will certainly keep you posted. I think it's already been discussed. Really huge barrier to entry is just that certification process. 5 to 10 years just to introduce a new material, new process into the system. If we can figure out a way to accelerate that process, not only on the aerospace and defense side, but in all of our industries. And I think the FDA, as well as the Department of Defense, have a lot to contribute to this area, and we would definitely appreciate your help in making that dialogue happen.
Well, thank you, and again, thanks to all of you on the panel. It's been a very informative morning. Seeing that there are no further members wishing to ask questions, I will thank our witnesses for being here today. Before we conclude, I would like to submit the following documents for the record by unanimous consent. A statement for the record from the American Chemistry Council, without objection, so ordered. I'd also like to submit a letter from the Specialty Equipment Market Association, without objection, so ordered. Pursuant to committee rules, I remind members that they have 10 business days to submit additional questions for the record. I ask the witnesses to submit their responses to those questions within 10 business days upon the receipt of those questions, and without objection, the subcommittee stands adjourned.